I would like to begin, and the topic today is sustainable manufacturing, current and future trends. Now, sustainable manufacturing has been talked about for a very long time. I think everybody knows what is sustainable manufacturing. And so let me tick through it very quickly. Okay, very quick definition. Sustainable manufacturing and sustainable development is actually the development which meets the needs of current generations without compromising the ability of future generations to meet their own needs. But this is actually a very general definition. Everybody uses this. What does that mean is whatever we are doing now, it should not affect the future generation. You see, we are producing a lot of discharge into the sea, discharge into the air, and so on. So whatever we are enjoying a good production environment, it does not mean that in future the same can be promised. Okay, I think this is again a very well understood diagram. It's a balance of three elements: social, economic, and environment. So this is a balance of all the three. And of course, you know, we can meet all of them, then it will be a very good situation. Now, these, again, the three elements is social, economic, and then the three pillars, we call it the triple definition. I go through this very quickly because, and of course, we know the reason is because water is a problem, and renewable energy is a problem. Now, everybody is switching into wind, solar, and so on. In fact, I tell you honestly, the best energy is actually nuclear. Nuclear energy is the best. Highly efficient, very clean, but safety is an issue. And of course, we know that safety can actually be controlled. Now, the Fukushima accident actually is not due to the fault of the nuclear plant, but due to the earthquake. And the earthquake has actually resulted in the meltdown of the nuclear reactor, okay? And the Earth resources are limited. And then we said that the world population is going higher and higher. We already heard the news. China used to lead the world's population. It has been overtaken by India. And I was even jokingly telling my friend, that's the only thing India can overtake China. I don't know about the rest of the population wise. Yes, they do. I'm not sure when I'm offending anybody here or not, you know. So, but that is a fact. So this is the kind of chart for the population. And then we know that the waste is piling up. Very interestingly, there's a new type of waste. It's called the electronic waste. And you'll be surprised to see mountains of mobile phones. Now, mobile phones is, you know, every few months you have a new model. So people just check it out and then didn't think of trying to recycle the mobile phone, okay? And then other ways of treating it is, for example, you can landfill. But landfill, after a while, you run out of space. And landfill is not simply by dumping waste into the earth or dig a hole. You have to have a lot of you know, preparation to make sure that the lichens and so on are being properly collected, okay? And then increasing legislation, we have more legislation every day. So what is the viable solution? This one we all know: reduce the use of raw material. Reduce, this is called, make it lighter and yet just as strong, okay? And that means that you have to use a different kind of material, but the cost need to be balanced. Reduce the energy associated with manufacturing. We try to use a material that consume a lower energy level, and then also easier to fabricate. Reduce pollution, reduce recycling. But my talk for this morning are not those topics, because everybody knows these topics. What I really want to talk about is remanufacturing. Now, remanufacturing, people get confused with a few terms like refurbishment, repair, demanufacturing. Now, they are different things altogether. demanufacturing is actually you disassemble the complete thing and then try to recycle the materials and so on. That's demanufacturing. So at the end of the demanufacturing, you will not have a workable product. But remanufacturing is you try to salvage the core component. Actually, we call it a core, and then you recondition it, and then to bring it to the same working condition as before, and the product become a usable product. Okay. Now, remanufacturing actually is to take a part down to the component level, and then reuse the components, making new products. The highest value, least energy consumption processes are being considered. And then this actually contributes to economic, environment, and also social sustainability. Now, some of those parts that can be salvaged, these are what we call the cores. Core represent a most important part of a product, right? So if you can reinstate the condition of these cores and put it back again, you can actually reuse the entire thing. But the process is actually quite complicated. It consists of inspection, disassembly, part replacement, refurbishment, cleaning, and so on and so forth. Now, very often people will ask, who would use a remanufactured product? Well, you'll be surprised, because if a remanufactured product is as good, almost as good as a new product, and you pay 30–40% less money, and of course people want to use it. But there are a lot of pre-qualifiers. One of them is that the product must have a very long stable life. Long stable life meaning that the product should still be in the market for the next 10–15 years. And also the product must have a pretty good high value to begin with. Now, you don't remanufacture a calculator, or you don't remanufacture a watch, but cars, tractors, aircrafts, ships, and also military equipment. Now, military equipment actually is a very good candidate for remanufacturing, especially when a country is not preparing for war. They only use the equipment for practice, for training, and so on. In fact, take the case of Singapore. Now, we're not going to have war with anybody, but there are lots of tanks, there are lots of military equipment. So after 10 years, they said that this equipment is no longer serviceable, and then they want to scrap it. Well, that's a waste of money. You could actually remanufacture it and use it for another 10–15 years. But after all, you are only using it for training, right? Singapore is not going to go to war with anybody. I mean, we're a small country, and then probably the war will be finished in a couple of days with the attack of the larger countries nearby. But that is not the point. The point is we could reuse those equipment and save a lot of money. Okay. Now, this map shows which are the countries that have been engaging in the various kinds of remanufacturing activities. Here, US and Canada, Europe, some part in Africa, mainly in the South Africa region, in Brazil, and then here in China, in Southeast Asia, in Australia, etc. So there are actually many countries that have practiced remanufacturing. For example, in Japan, this is sometime back because nowadays nobody uses single-use camera anymore. That is the film stage, right? But photocopiers, they remanufacture. In China, there's automotive remanufacturing, and Caterpillar's Earth Mover, Cummins, Volkswagen, and all established the remanufacturing. In Singapore, we look at aircraft engine overhaul, crane, Caterpillar remanufacturing facilities, and so on. Okay. Now, there are a few categories here. One is called repair. Now, repair actually is the process of restoring damaged parts back to functional conditions. Now, that's actually not remanufacturing. That's repair. Okay, repair, when your car is not working, something's gone, you send the car in to repair. The garage man will put it to work again. Refurbishing and reconditioning, again, this is not exactly remanufacturing. And then recycle is the worst, because recycle essentially you strip scrap the metal and then you recycle the material, okay? Now, for remanufactured products, you actually receive a warranty. A warranty will be given to a remanufactured product. It could be 6 months, could be 1 year, and so on. And the remanufactured products actually have very high levels of quality and performance, right? They may lose their identity. Some parts that cannot be remanufactured are replaced with new components, right? But interestingly, remanufactured product can outperform the original version. Now, original version meaning that the product that was produced, let's say, 10 years ago, and now you remanufacture it, actually is better than the product 10 years ago. The reason is very simple, because it has been replaced by better components, better control, and so on and so forth. But of course, it's probably not comparable to a brand new product which is made now, okay, which has even more functions, electronic controls, etc., and so on. But then, of course, you pay much less. Whether you need 100% functional product or you are happy with a 80%, 90, 70% functional product, and yet pay a much higher discount for it, okay? Now, for example, like a vacuum cleaner, and I wouldn't buy a Dyson vacuum cleaner. I mean, it's efficient, no doubt, but it's crazily expensive. You know, I would buy a vacuum cleaner, which is much cheaper. And at the most, I sweep my floor a few more times, right? Dyson can do it 1 time, I can do it in 3 times. But that kind of thing is, whether if you will pay for a remanufactured Dyson vacuum cleaner at 50% of the price, some people may consider that. Now, there are many procedures here. I just want to go through it quickly. Cleaning, inspection, sorting, disassembly, reassembly, inspection, and testing. Now, remanufactured, let me just put it in the right perspective. It's different from the manufacturing of a new product. Manufacturing of a new product actually is more straightforward. The reason is you know exactly the assembly procedure, the sequence, and how to put it together, how to test it, and so on. A remanufactured product, just imagine you receive a product, it could be a car engine, which is already 10 years old. When it comes in, usually it's greasy, dirty, and some part may have been corroded, right? So you have to, first thing you have to start to clean it up and decide what can be salvaged, what cannot, and how to disassemble this. So disassembly become a very key point in remanufacturing. In fact, I was telling the students, if you design a product which is extremely difficult to be disassembled, then your product cannot be considered for remanufacturing. And sometimes, you know, it's like you have to break a few parts in order to take them apart. And that is also become not friendly for remanufacturing at all. So now we come to the point is a lot of people talk about design for assembly. And now we have to come to a new point called design for disassembly. Now, disassembly is a lot more difficult. Assembly, you can use robot and so on. Up to now, I have not seen a robot able to disassemble a part completely. It's not easy at all because parts are corroded, and a robot first have to identify whether it's a corroded nut, how to deal with it. Can it be loosened, or you have to cut it away, and so on and so forth. So unfortunately, disassembly, a lot of it is still done manually. Right. Benefits of remanufacturing, actually, it's more profitable than conventional manufacturing, right? And later on, I will explain. But of course, from the sustainability viewpoint, remanufacturing is very good because it preserves the material, preserves the energy, it preserves and reduces impact to the environment, etc. All right. Use less energy and raw materials because essentially the material is already there, right? The material is already there in the product. You see, you don't have to cast the engine again. All you need to do is to refurbish some of the cylinders and pistons and so on, etc. Right? And then also manufacturers can benefit from legislations, because carbon trading and carbon emission will be reduced. And later on, I think we will speak, we'll talk about carbon effect of carbon footprint, etc. So remanufactured goods can actually enjoy a much shorter lead time. So if we look at this summary here, remanufactured engines can reduce 68 to 83% energy, and then can be purchased at a 30 to 53% cheaper price. And also the remanufacturing industry has created a lot of jobs in the UK and elsewhere. They employ a lot of people. There's something like over 50,000 at that time, and now will be a lot more than that. So why remanufacture? This actually, if you look at a new product, you have a few components: the material component, the labor component, energy, and also plant and equipment. A remanufactured product can actually preserve quite a lot of that material, almost all preserved, and then energy previously spent and now it can be preserved. Compared to a recycled product, you can only recycle some of the materials. All the rest, unfortunately, all disappear. Once you burn down or you disassemble, recycle an engine, of course, the labor originally used to build the engine, all this will be gone, right? Now, what are the general qualities for remanufacturing? Firstly, you must have a long and useful life, right? And stable technology. It should not be displaced by disruptive technology. Now, disruptive technology actually can be quite frightening. It's a new technology that comes. Initially, it was like replacing an old technology, but at the end of it, it completely wipes out the old technology. Frightening. I'll give you an example. Calculators now wipe out by mobile phones. Every mobile phone has a calculator built in, right? And then, of course, going back again, typewriter. Now, who used typewriter? I don't even think any one of you has used a typewriter before. Now, during our days, you know, we all type our thesis reports using typewriters, but that has long time been replaced by computers, right? And watches, analog watches all disappear and now replaced by digital watches, except the very expensive high-end watches, Patek Philippe and Constantine and so on. Those are still analog. The reason is people pay for the craftsmanship, the precision, and not just an electronic circuit inside a watch. I will not pay $100,000 for the watch if it's electronic. I will go for a manual, classic Swiss assembled watch. All right, you pay for that. I mean, why you pay for a chip for that kind of money? It's more than a chip. Outside you're stuck with diamond, but then you're only buying a piece of jewelry, so it's not a watch. Okay, and you need a distributed network of transportation, and then you need to have workshops and then special training sections. You see, now a lot of people have been interviewed. They work on the production line and they work in the remanufacturing plant, which is more exciting. I can tell you 100% of the workers will tell you remanufacturing is a lot more exciting. Production plant, you are working like a robot. All the sequences are fixed beforehand. That's nothing exciting, you know. Every day you just put things together, test it and so on. But remanufacturing, you know, when a product comes in, firstly, you have to look at it. What's wrong with it? And then how to put it apart and how to clean it and how to put it together. Every case is different. That is where the excitement is. You don't want to do the same things over and over again. You want to look at individual new cases, right? But of course, you know, the problem is not all companies would like to consider remanufacturing. And in fact, the best people to do remanufacturing is the OEM themselves. OEM is original equipment manufacturer. The reason why OEM is best because they have all the parts, they have all the tools, and then they know the sequence of the new product, and now they apply this sequence to the used product. That is the best. But a lot of OEM, they don't want to do it because they feel that they are producing two types of equipment. a new equipment, a used equipment, and there can be some confusion and to a buyer whether I'm buying a new equipment or I'm buying a remanufactured equipment. But of course, you know, the companies, they have to be very sure about this. They have to stamp it on the certificate and tell you that this is actually a remanufactured products. Okay. This is kind of work that we did at the university, and then we come out with a plan starting from design for remanufacture, right? And then look into how we service and monitoring and examine the remanufacturing facilities, and then study the cost and inventory management, and then the remanufacture assessment. This is kind of a talk. And then we can start out with a CAD analysis and knowledge-based development. And then here we can start out with a CAD model, extract all the features, build a material, fastening, joining, etc. And then we come up with assembly model. And then we look into this disassembly, accessibility, repairability, complexity, and so on. And then how we come up with an overall plan for the remanufactured product. There are a lot of approaches, mathematical tools which can be used. Some of them are like HGPR, hierarchical graph representation, and also assessment metrics and the similarity functions, etc. This is kind of output from the program that we design. And an example we use is actually a electric reducer. And then we consider how this is taken apart and which are the parts that we cannot use and where is the core. The core actually represents the most important part of the product. There are a couple of different ways. One is called to design it to embedded assembly and hierarchical. There are different levels. In other words, when one part is done, and then you go to the next part, and so on. And then the modular and the active disassembly. Now, modular actually is one of the best. You can take it apart easily using modules. This one actually, there's some thoughts about it, meaning that if you add current at temperature, the part can actually return to its original state using memory, alloy, and so on. So in other words, when a engine comes in, you apply some kind of activation, then the parts slowly disassemble by itself. Now, this actually is kind of like a fairy tale story. It doesn't work that way. You know, it's not so straightforward. Maybe certain elements you can do that, but definitely not an entire engine. You pass electric current through it and all disassemble by itself. Now, this can be also dangerous. Can you imagine you're driving a car, suddenly you went through some high energy current field, and then you found that all your parts of the car are actually on the road, right? It has been fully disassembled. It's not going to work that way, okay? Research motivation, their number. Ensure remanufacturability, reduce assembly, disassembly time. This is the part that we look at for the engine part to decide the various factors. Now, typically, like a vehicle remanufacturing, these are certain. This is actually another big area is remanufacturing of machine tools. Now, many machine tools actually can be used for a long time. All you need to do, maybe you need to see to the spindle, need to see to the controller, and then the slideway and so on, okay? This is actually quite involved. I go through it quickly. And certain parts to be taken note of, consider remanufacturing. There are lots of decision-making tools. In fact, Dean Mann already mentioned earlier on, manufacturing is not a single disciplinary kind of activity. It involves a lot of other consideration. For example, here we have to look into the QFD, look into GTA, look into AHP, and so on and so forth. There are many tools that can be used for remanufacturing, because these tools are more on the side of industrial engineering than mechanical engineering. Manufacturability assessment, in fact, again, there are quite a number of it. As I mentioned earlier on, it must have a good lifespan. It must have a good lifespan. In other words, the product must have last a good number of years. And then also you look into the environmental impact and the other issues. Now, not all factors can be equated on a similar basis. This is a little bit difficult. So we actually come up with an item called remanufacturability index, using this index to assess whether a product can be remanufactured easily or not. Okay. Now, 6 strategic enablers are: what is the product value, benefit added? What is the product life? Recoverable value, remanufacturing capabilities. What are the business opportunities and environmental impact? Now, all of them need to be analyzed before you can come up with a viable solution. And a significant reduction in environmental impact can be made. That is actually quite a major contribution of remanufacturing. And also it's rather difficult because I'll tell you what are the most difficult parts. You have to collect use cores from products. Now, very hard to predict when those use cores will come in, right? And then at what frequency. So this becomes a very difficult way to forecast. And because different equipment which has been used in the field, some could last much longer, some would only last a very short time. So it's difficult to do a forecasting, right? So therefore, the inventory is actually a big challenge. How do you prepare that inventory? How do you prepare the inventory to meet the remanufacturing? And to make it more complex, there are many, many versions. I mean, you just look at a car. Every 3-4 years, they come up with a new model, right? A new model would have different parts and so on and so forth. So that becomes a mixture. You have to identify whether this car is 2005, whether this car is 2010, and then you have match it with different components, different kind of facilities and so on. Okay. Now, constraints and challenges. There are lots of constraints. Listed here. Availability and cost of replacement parts. Increased product diversity, which is very true, getting very diverse, and various cleaning process. Now, parts are corroded. How do you clean it? Complexity in design, varied fastening methods, and increasing part fragility, and so on and so forth. The fastening actually is a very major concern. And a lot of parts are welded, and those parts cannot be dismantled without cutting it out. So not to design welded or use addition to fix the parts together. This is one way for design for remanufacturing. In fact, I was telling the student, nowadays, a lot of parts are actually fixed together using snap fit. Now, snap fit sounds very easy. You just put it together, you hear a click, they're fixed together. But how do you unclick it is very difficult. It's not easy. Either you have to use a special tool, or you may even have to damage the click joint before you can even dismantle it. And then I taught the module actually called Design for Sustainable Manufacturing and Product Fabrication. This particular module actually asks the student to pick an actual product, whether it's a vacuum cleaner, whether it's oven, whether it's a stove, and so on and so forth. And then they have to analyze it using software called Eco 99 or other software to analyze the kind of materials and then look at the final carbon footprint and then to decide what to replace and how to improve, right? The constraint and challenges. Increased pressure to reduce remanufacturing lead times. This is the one. And how do we reduce it? And there's lack of formal systems, operations, accounting, logistics, and so on. And then lack of cost. Cost means the most important part. You don't have the cost. You cannot collect enough cost. It's very difficult to carry out the remanufacturing. Products are designed for disposal, then there's no point to remanufacture. And also technology changes are very fast. And so considering all these points, not many products are suitable for remanufacturing. So you must decide which are the products you want to handle, okay? And then also need a different mindset and a shortage of skilled labor. Now this actually become a very skilled labor. Imagine this, we are not back to like a job shop situation. A job shop worker actually is a very skilled worker because he has to handle almost all the different operations. It's not like a flow shop. Each one is looking into a certain part. He's not bothered with the parts before or after, right? A job shop is a very skillful worker. And then this kind of labor is very hard to find. And then very often there's no good correlation between the supply of return products and demand for remanufactured products, okay? And here again, I summarize a few points, which I won't go through all of them. And what I normally use to describe remanufacturing in two words, we call it SS, sporadic and stochastic. This is how it describes the remanufacturing process. It's sporadic and it's stochastic. Very hard to forecast. It's very hard to predict, okay? Change your mindset is very important. And then provide the service the customer requires, and also allow the company to take back the products. As consumers become more affluent and process greater spending power, and actually they want new products, right? And then new models in a very short time, and also take back products. You take back, and then you could, okay. Most environmentally friendly, and also provide remanufactured parts can provide excellent performance, and remanufacturing industry actually has support a lot of research activities. Okay, now I'm not going to go through all of them, but this is actually what are the necessary actions required from product design and all the way to reassembly, inspection, etc. And then what are the mathematical tools taken? It's lots and lots of mathematical tools: Taguchi, Topsys, fuzzy logic, house of quality, linear integer programming, queuing theory, design reuse, axiomatic design, and so on. And this is a kind of market growth for remanufacturing for comparison. And this is actually only looking at automotive parts, actually it's growing very rapidly. And very quickly, I show you some of the slides of Singapore's R&D effort in remanufacturing. A-Star, Singapore's Institute, and they started this remanufacturing project about 12 years ago, and then put in a lot of funding support. And they have built up actually a very good line for handling remanufacturing. and they involve assembly, finishing, using 3D printing to do repair, like laser cladding, surface enhancement, product verification, machining, and so on. Repair and restoration is one of the major parts. And area of focus, for example, perform cleaning, minimum use of chemicals, and remove defects, and using additive techniques for part regeneration and repair. This is where the additive repair of aerospace parts are being carried out. Surface enhancement, and again, to make the surface treatment. Some additional, like shop peening, burnishing, etc. And surface enhancement, and then the measurement and testing, and then product verification. So after that, I need to verify products. There are lots of focuses here. I'm not going to go through. And then the product verification, and then again using scanners, laser technology to measure the defects. Additive manufacturing is used quite a lot because it can be used to repair a lot of parts by doing cladding, etc. Yeah, this is, and again on additive manufacturing, laser cladding. Okay. Time is almost up, so we'll come to conclusion soon. And the remanufacturing is necessary for sustainable development, and then also business models need to be changed in order for it to be successful. Mindset change, and the consumers will have more peace of mind. Companies also will profit more. Environment will be conserved. This is kind of summarizing the process altogether. Inspection, disassembly, cleaning, remanufacturing, reassembling, testing, certification, and going back, right? So future remanufacturing, again, involve a lot of automation. Although in the beginning I said remanufacturing is largely a manual process, but it can be automated to various extents. For example, you can use imaging, hyperspectral imaging techniques to find out where the faults are. A digital twin can also be used to monitor the product before and after. And then you can use a neural network to do the optimization to find out the best path for disassembly. And then you have backend programming. And then after that remanufacturing process, you can use some automated equipments to put them together and put it into the warehouse. So in future, I think we are looking towards a remanufacturing plant, which is largely manual, and we convert it into more automated kind of a process. Now, this is actually one area where a projective AR system called AR Kite has been used. Now, AR Kite, what it does is it does not use HoloLens or head-mount device. It's projected from the ceiling with projectors mounted. You can actually project it onto a workbench and identify which are the parts you should take out first, etc., and so on. So this becomes a very useful system. Both are using AR Kite and applications. And this one, actually, you can find it from easily from the website. They have a training section how to use the AR Kite. This is actually by John Deere. John Deere actually has a very large remanufacturing plant. Okay. Some of the global industrial figures can be seen here. There's lots of growth. So we call it remanufacturing a win-win-win scenario. Now, what is a win-win-win scenario? Consumer pay less, manufacturing earn more, and environment receives reduced impact. So this has actually become very good. So I'll show you. Reman is a thing to go. Okay. some of the publications that we produced on remanufacturing and books produced. This is actually very recent. It was just published earlier this year. And it concerns how we actually make an assessment for the remanufacturing. Okay, I think with this, I ended my lecture. Thank you.